Hi everyone, we're starting our next video on solving quadratic equations. We're going to be looking at Chapter 9 and Chapter 17. And the first thing we're going to take a look at is all the different methods that there are for solving quadratics. Now, as far as we know so far, the only method that we have used to solve quadratics is to factorize. So we've done different types of factorization. Factorization that has involved sum and product, removing common factors is another form of factorization, along with splitting the middle term. And we have also looked at regrouping or removing common factors. Okay, but there are at least three other techniques or methods that we could use to solve quadratic equations. And one of those is completing the square, which we will be doing in the next couple of days, using the quadratic formula, which we have already touched upon, and just by using our calculators or technology. Now, what you are aware of is that ax squared plus bx plus c is really our general formula for a quadratic, where the value in front of the x squared is always considered a, the value in front of the x or the linear term is considered has a b in front of it, and c is a constant. When we are writing quadratics, we are always writing them in descending order of degree, meaning that we go from x squared to x to the constant. Okay, now before we get started on solving quadratic equations, and solving usually means what? It's referring to finding our x-intercepts. So in order to find our x-intercepts, we normally let y equals 0. Now, if y is equal to ax squared plus bx plus c, it would make sense to say then, in order to find my x-intercept, I let y equal 0. And that's why we set them equal to 0, the quadratic equations. Now, before we move on to actually solving the equations, we should just review very quickly the null factor law. And all the null factor law is telling us is that if we have a product of terms, such as a and b, and they are both set equal to 0, then that means that either one or the other is equal to 0, or both. And therefore, that's why we end up setting these equal to 0. Now, let's take a look at our first problem. So if I've got 3x squared plus 5x is equal to 0, the first thing I want to do is I want to make sure that all terms are on one side of the equation and that the equation is set equal to 0. So because this is already set equal to 0 in part A, then I can focus on just at this point removing a common factor. So the method I would use here is to remove a common factor. And the common factor that I would remove can only be 1, if not just x. So that I'm left with a 3x plus 5 within the brackets or within the parentheses. Now, having gotten this far, all we need to do at this point is we just need to use the null factor law. And the null factor law says that because we do have a product of terms here, it's x multiplied by 3x plus 5, then that means that x is either equal to 0 or 3x plus 5 is equal to 0. Now, x equaling 0 will just remain x equaling 0, and then I can proceed to solve 3x plus 5 by isolating for x, so that I have 3x is equal to negative 5, and x is equal to negative 5 over 3. Okay, so that tells us that our two solutions are x equals 0 or x equals negative 5/3. Now, when I am solving here, what I'm actually solving for are the x-intercepts. So I'm looking for where the x-intercepts are. Therefore, I can make a very, very quick sketch here, and I could say, well, my graph is going to look approximately like this, where I know that it's going to be going through the point 0, 0, and then the next point over will be found at negative 5/3. That would be my next x-intercept. Now, there are three ways, at least, that we can describe the x-intercepts or solving for a quadratic. So we could be looking for the roots, we could be looking for the zeros. So you could be told to find the roots or find the zeros, find the x-intercepts. So we could say find the x-intercepts, or it could just be find, solve for x. Okay, so all of these have exactly the same definition. The next question has x squared equals 5x plus 6. So we're going to bring everything over to one side of the equation so that we'll write it in descending order from x squared minus 5x minus 6, and that's going to be set equal to 0. And from here we're going to use the sum and product. So sum and product, if you recall, just means that we are looking for two numbers that multiplied together will equal, so multiplied they will equal negative 6, and the sum of those two numbers has to equal negative 5. So if I look for the factors of negative 6, well, the factors of negative 6 are going to be either negative 6 and 1, or 6 and negative 1, or they could be negative 3 and 2, or 3 and negative 2. Now, based on these four possibilities, and if I look at what my sum has to be here in the middle, I've got negative 5x, I would, at this point, I would say that the numbers are going to have to be negative 6 and positive 1, because otherwise negative 3 plus 2 would give me a negative 1. So now we have that we've got x minus 6 times x plus 1 is equal to 0. Now, because we have a product of the factors, then now we can take a look at, or product of terms rather, then we can then now use the null factor law, which tells us that either x minus 6 is equal to 0 or x plus 1 is equal to 0. And therefore, we can just we can isolate for x, where x is either equal to 6 or x is equal to negative 1. Again, keep in mind this means that we've got x-intercepts at, if I'm drawing this out very quickly, I have an x-intercept at x equaling 6, and I have another one occurring at x equaling negative 1. So it looks approximately like this. Again, this is just a sketch, and therefore that's that. Okay, the third possibility that we have here, part C, is a question where, if you recall, we've got a situation called perfect squares. Now, I'm just going to do this off on the side here. Perfect squares is when we have this situation of a squared plus 2ab plus b squared. And what is that basically telling us? It's telling us that we are squaring the first term, we are squaring the last term, and then we take the product of the two terms a and b and then multiply them by 2. Now, that would be occurring if I had something like this. So if I had 2x plus 4, for example, and I squared it, that would be a perfect square. They are identical binomials. So instead of actually foiling this, and just so that I could say 2x plus 4 and 2x plus 4, okay, so this is foiling it. I would be doing 2x times 2x is 4x squared. Then I would have plus 8x plus another 8x, and then plus 16. And that would give me my final answer of 4x squared plus 16x plus 16. Now, what I can do is that when I have to factorize, well, the first thing I'm going to do is I'm going to bring everything over to one side, which is already here. If I have to factorize this, I can take the square root of the first term, and I can take the square root of the last term. So the square root of 4x squared is 2x, and the square root of 16 is 4. Now, I can check to see whether this is a perfect square or not by simply saying, if I square the first, I get 4x squared. If I square the last, I get 16. If I take the product of these two terms, 2x times 4, and then I double it, it goes to 16x. And therefore, I know that 2x plus 4, all squared, is my perfect square. Now, knowing that at this point that I've got 2x plus 4 all squared, let's go back now and take a look at the original question. So I recognize this very quickly as being a perfect square, but you may not do that quickly. So what I do is I do 4x squared minus 4x plus 1 equals 0. I brought everything over to one side of the equation. I took the square root of the first term, which was 2x. I took the square root of the last term, which is 1, and then I said, okay, if I've got 2x and a 1, if I square the first, it goes to 4x squared. If I square the last, it goes to 1. If I do 2x times 1 and then multiply that by 2 again, or double it, that goes to minus 4x. So that means that I must have 2x minus 1 all squared. So I know that 2x minus 1 all squared is equal to 0. Okay, now in order to isolate for x, I will take the square root of both sides, and I end up with 2x minus 1 is equal to 0. And now I proceed to isolate for x, where I have 2x is equal to 1, and x will just equal 1 over 2, which is 1/2. There is only one root in this case, and the reason why there's only one root is because it's the same root. When I expand 2x minus 1 all squared, so when I do 2x minus 1 times 2x minus 1, well, that gives me the same root being 2x minus 1 equals 0, and 2x minus 1 equaling 0. So I have exactly the same thing. Now, if I take a look at Part D, Part D is a little bit more complicated because Part D is not a sum and product question, but it's a splitting the middle term question, which, by the way, I could have done also in Part C. I could have split the middle term. So we're just going to go over very quickly last year's lessons on splitting the middle term, and hopefully you'll remember quickly how this was done. So what I do again is I take everything and I bring it over to one side of the equation. So I have 6x squared minus 11x minus 10, and that's set equal to 0. Now, because I cannot have a value in front of the x squared term other than 1, and I can't get rid of it because I can't remove it, 6 doesn't go into 11 or 10, then what I do is I multiply my first term by my last. So I multiply a times c, and I end up getting negative 60. Now, the sum of the two terms has to still equal the value of b, which is negative 11. So now I am looking for the product of two terms that multiply to negative 60, but that add up together to negative 11. So I start by writing out my first term, which is 6x squared, and I write out my last term, which is negative 10. And what I do with the middle term is exactly what I say. I am going to split it, so that I'm going to take all my factors of 60, and there's quite a number of them. So the factors of 60 could be 10 and 6. They could be 30 and 2. It could be 15 and 4. It could be 20. It could be 20 and 3. Okay? It could be 60 and 1. There's a number of factors, but the one that would work out to give me negative 11 as a possible answer, and because we have two negatives, we have a negative and a negative here, that means that the product needs to be negative, but the sum also needs to be negative. So one term is going to have to be negative, and the other term is going to have to be positive. So that I'm going to take a look at this and say, well, 15 minus 4 is going to give me 11. So I'll do minus 15x plus 4x. Now, I've split the middle term. Now, because I've got 4 terms here, if you remember from last year, what I can do is I can divide them up into 2 groups of 2. And I remove what's common in the first 2 terms, and I remove what's common in the second half, or the remaining 2 terms. And what's common to the first 2 terms here that can be removed is definitely a 3x. And what's left over is a 2x minus 3. Now, when I look at the second half of this expression or equation, what I see is that I can take out, again, a 2. And what's really left over is another 2x minus 2x minus 5. I was wrong on the first one, because when I remove 2x, when I remove the first one here, 3, when I remove a 3, it doesn't go to 3, but it goes to 5, so that it'll be 2x minus 5. All right, now because these two are identical, I know I've done the problem correctly, if you recall from last year, and now I can remove a common factor, and that common factor to remove can be the 2x minus 5. So if I take out a 2x minus 5, which is common to both of these, what seems to remain is a 3x plus 2. So so these are removed, one is taken out, and what's left over is a 3x plus 2. And that's still equal to 0. I now proceed to use the null factor law, so that I say, well, 2x minus 5 is equal to 0, or 3x plus 2 is equal to 0. And then I isolate for x again, so that I say, well, 2x is equal to 5, and then x is equal to 5 over 2, or otherwise we have 3x equals negative 2, and x is equal to negative 2/3. All right, so those are my x-intercepts. All right, let's take a look at one other example. This other example has 3x plus 2 over x equals negative 7. I don't seem to have a quadratic right here, right now, but if I looked at the fact that I've got an x in the denominator, I do not want to have a fraction, I don't want to have a denominator, so if I multiply the entire equation through with x, I end up getting 3x squared plus 2 equals negative 7x. And from there, I will say 3x squared plus 7x is plus 2 plus 7x plus 2 is equal to 0. So I just brought everything over to one side. And I'm going to use the null factor law again, because I cannot remove a common factor here. So very quickly, I'm going to do 3 times 2 is 6. So a times c, the product of the first and the last term is 6, and the sum of the two has to be equal to 7. So my only terms, or my only factors here, are 6 and 1, and 3 and 2, and I think that 6 and 1 will do it. So I will write down my first term, which is 3x squared. I will write down my last term, which is plus 2, and then I will split my middle term into 6 and 1. So it'll be plus 6x plus 1x plus 2. Again, we have now 4 terms. So if I've got 4 terms, I can divide it up into 2 terms and 2 terms. And therefore, I've got a 3x bracket x plus 2 is my common factor to remove from the first set of terms. And then I can remove a plus 1. And what's left over is an x plus 2 in the second half of this. Now, because x plus 2 is common to both of them, I can take it out to the front and say, okay, I've got x plus 2 now, and what's left over is going to be 3x plus 1, and that'll go again inside parentheses, 3x plus 1, and that'll equal 0. So now again, using the null factor law, we have x plus 2 equals 0, or 3x plus 1 is equal to 0. Both solutions must be given, so that x is equal to negative 2, or 3x equals negative 1, and x equals negative 1/3. Now, the only other thing that I wish to go over is I'd like to go over very quickly just another example, and I want to take the example of x squared equals 5x. Okay, I could really use any example, but I'll just use x squared minus equals 5x. Now, if I have x squared equaling 5x, I cannot, I repeat, I cannot just divide both sides by x to get rid of this and say x equals 5. That is incorrect. What I always must do is bring everything over to one side of the equation. All x's go over to one side of the equation, and the equation is set equal to 0. So that I have to say that x squared minus 5x is equal to 0. And now I remove a common factor where I have x bracket x minus 5 equals 0. And by using the null factor law, I get x is either equal to 0 or x minus 5 equals 0. So if you'll notice, I have two x-intercepts here as my possibilities. Either x equals 0 or x equals 5. Now, if you take a look at the example that I had over here, notice that I only got one solution here, and that solution was just x equaling 5. By doing this illegal type of cancellation, I know you find that funny when I use the word illegal, but by doing this type of cancellation, I am removing, or I am not including, another x-intercept that should be in that graph or on that parabola. So this parabola actually has a y-intercept at 0, 0, and then another one at 5, 0. So if I say that the answer is only 5, well, that means that it only has one x-intercept, and that's not the case because this parabola has two x-intercepts. So by doing this illegal type of cancellation, you are avoiding, or you are not going to be getting the all of the roots the way you should. That's why we should bring everything over to one side of the equation, set it equal to 0, and then proceed to remove a common factor or use sum and product or split the middle term. All right, the very last question that I'd like to go over, and then it's done, is I'd like to take very quickly another look at an example such as 3 bracket x plus 2 times x minus 4, for example, and that's set equal to 0. Now, the first thing that I would do is, because there is no x set on this 3, but everything else is a product where it has x's inside the parentheses, I would divide both sides by 3. 3 goes into 3 once, and then 0 divided by 3 is always going to be 0. So that we have x plus 2 and x plus 4 is equal to 0, and therefore, using the null factor law, x plus 2 either equals 0 or x plus 4 is equal to 0. So x equals negative 2 or x equals negative 4. The very last example I'm going to give you is an example that looks like this. X plus 4, take the square root, is equal to 16. Oh no, let's make it 25. Is equal to 25. Now, I need to take the square root. I need to square both sides. In squaring both sides, I'm removing the square root. Okay, and in doing so, then what I'm going to do is I'm going to end up getting x plus 4 is equal to 625, and then x would just equal to 621. That's one example. Another example would be to take the exact same question, except how about we call it x plus 4 all squared is equal to 25. So that in order to get x by itself, I'm going to have to square root both sides. And in square rooting both sides, the squared and the square root cancel themselves out, so we just end up with x plus 4 equals. Now this is the part that everyone needs to remember, is that it equals the positive or negative version of 5. Because the square root of 25 is equal to either the positive or negative of 5. So when I have to do my answer here, I'm going to have x plus 4 is either equal to 5, or x plus 4 has to be equal to negative 5. So I will come up with two answers here. My x will equal 5 minus 4, which equals 1, or my x will equal negative 5 minus 4, which equals negative 9. So therefore, we have here, again, two x-intercepts. You have to be really careful in making sure that you are getting all the proper intercepts. All right, that's it. The homework is on Power School. It's under this lesson, and Again, we're on Play Pause It, so you can watch the video again if you need to, and please complete the homework in class. See you next time.